Hello everyone, I hope you're doing well. This study is about the relationship between normalized difference vegetation index NDVI and spatial distribution of urban heat islands or UHIs throughout the city of Shiraz. In recent years, urban heat island impacts have attracted more and more attention due to their possible environmental problems affecting people's normal life. Our attempt in the study was to demonstrate the spatial distribution of heat islands in Shiraz and explain the features of Shiraz's spatial distribution of heat islands through different districts according to present status of green lands in the city. For this purpose, qualitative and quantitative analysis have been applied to investigate the relationship between NDVI and UHI. The output of this work can provide certain scientific supports for Shiraz urban and green lands planning in the future. Rapid population growth in cities, large-scale urbanization with increase of the asphalt and built-up surfaces, and accordingly declining in green spaces and evaporation surfaces, expanding in industrial and commercial uses, and heavy traffic result in the intensity of urban heat islands throughout the city. 5 common characteristics of urban heat islands are: first, UHIs have higher temperature than the rural and nearby areas. Second, the urban-rural temperature differences are higher in calm and clear weather, night and winter. The third one, more urban development and less parks and green spaces correlate to the intensity of UHIs. And last but not least, UHIs warm the weather above the cities. Our study area was Shiraz City, which is placed in the central part of Shiraz County and embraced about 1.70% of whole county. Shiraz has a population of 1,869,000 at 2016 census. It has a moderate climate and which is generally classed as hot semi-arid climate. In Shiraz, the winters are cold and mostly clear, and summers are sweltering, arid, and clear. Over the course of the year, the temperature typically varies from 32 Fahrenheit to 99 Fahrenheit, is rarely below 26 Fahrenheit or above 103 Fahrenheit. Shiraz's climate has distinct seasons and is overall classed as hot semi-arid climate. Due to continuous constructions in the city, lush gardens and country yard houses have been replaced with high-rise apartments and small parks. Urbanization and human activities such as raising temperature, which is driven from using of low albedo materials in urban spaces, especially in summers, increasing numbers of buildings and construction in city, and decreasing in trees and vegetation are causing intensification of UHIs, which affected the urban lifestyle, urban culture, and the built environment. As a conclusion, lack of greenery, low quality of albedo facades, concrete zones, and high concentration of anthropogenic activities in urban spaces are quite substantial issues which lead to intensity of UHIs in Shiraz. Shiraz embraces 10 municipal districts, which have different population densities, several of construction patterns, and disparate green spaces per capita. This specification and variety in urban features lead us to a general conclusion about spatial pattern of urban heat islands throughout the city. In these two maps, the first map we have distribution of population in municipal district, and the second one is green space area in municipal district of Shiraz. As you could see, second, third, fourth, and seventh districts are most populated, and on the other hand, third, sixth, ninth, and 10th district have the highest percentage of green spaces per capita compared to others. Considering these differences make us able to realize the correlation between greenery and distribution of UHIs in a city. In here, we have at map 1 distribution of urban heat islands in Shiraz, and in map B, we have intensity of urban heat islands in municipal districts of Shiraz. LSD products of night from Sentinel-3 have been used in this study to map UHI distribution, and the prospective date of acquisition of the image was July 25, 2021. Data was obtained from Copernicus website, and the acquired pre-processing operations such as radiometric and geometric correction have been done to make the image usable. Further, other steps were followed to extract UHIs from surface temperature. The whole procedure was done in SNAP and QGIS. In map A, we have normalized difference vegetation index in Shiraz, and in B, we have value points. Satellite images of July 2021 have been utilized in the study for producing NDVI map. NDVI allows us to delineate the distribution of vegetation based on the characteristic reflectance pattern of green vegetation. For example, if the target or the object which being observed contains leaf green vegetation or not. This simple numerical indicator can be used to analyze the remote sensing measurements by calculating this equation, as you can see here, near infrared band minus red band divided into near infrared band plus red infrared band. NDVI could vary from -1 to +1. For example, 0.1 and below correspond to barren areas of rock, sand, or snow, and 0.6 or 0.8 are related to tropical rainforests. After the preparation of UHI and NDVI map by extracting some random points using research points and assigning values to them, we could discover the correlation between UHI and NDVI, as you could see in here, the value points map. A quantitative approach was used to explore the relationship among UHI and NDVI. All the pixels of UHI and NDVI raster layers were used in the regression analysis, where NDVI was considered as the independent and UHI as the dependent variable. A statistical descriptive of these two data have been brought in following chart. We have means and standard deviation, the numbers of these two indicators. The other one is Pearson correlation coefficient, which is applied in SPSS to find the relationship between these two indicators. Pearson correlation coefficient is a measure of linear correlation between two sets of data. It's the ratio between the covariance of two variables and the products of their standard deviation. Thus, it's essentially a normalized measurement of the covariance. The result always have a value between -1 and +1. The negative values represent inversely proportional and positive values show directly proportional. As much as it gets closer to absolute 1, the relationship gets stronger and more dependable. Linear regression is a linear model, assumes a linear relationship between the input variables x and the single output variable y. And here x is NDVI, as I told you, and y is UHI. Based on extracted data from input raster and modeling in SPSS, the following scatter plot is produced. The equation of this linear relationship, which has been brought in here, as you can see, in the scatter plot, in the center of this scatter plot, which shows that, UHIs is negatively correlated with NDVI. And the relationship, the correlation is not that much strong, it's very low. As a conclusion, the regression analysis between UHI and NDVI proves inversely proportional correlation between these two indexes. Although it's not very strong, as I told you, but it still remained. Areas which are under the green cover reported lower UHI effects. However, other factors such as land use cover, urban composition, spatial arrangement, and population density are involved and should be considered before reaching any final conclusion. The spatial pattern of UHI in Shiraz shows that while the north and south are relatively cooler areas, central, eastern, western municipal districts exhibit higher temperatures. The NDVI index displayed positive values closer to +1 in 2nd, 6th, 7th, and 10th district, which showed relatively lower UHI effects. The result of the study will be useful for urban planners and environmentalists in formulating local policies. Thank you so much for your attention. If you have any question, let me know.